Hello and welcome back to another student question answer video reply, and today we are going to be looking at the J10 syllabus, and in particular we're going to have a look at an email sent across by a student in relation to, it looks like, AER. Okie dokie. So as always, let's have a look at the question, apply any additional context, and then see how we get the correct answer, which the student hasn't provided here. So let's see if we can work it out. So, hi Sam, a question about converting interest rates from annual to half yearly. Okay, I attached my workings but clearly doing something wrong as I'm out by a factor and the numbers are not matching anyways. Okay, so a bad place to be in, I guess. So two deposit accounts pay an advertised rate of 2.4% per annum. However, X credits interest annually and Y accounts, whereas account Y credits interest half yearly. Okay, how much extra interest will a fund manager receive after a year if she invests 1 million with account Y, which is credited half yearly, then account X, which was just annually? Okay, so before I have a look at your workings, let's do a timeline. Okay, so with X and Y, we know we're getting some money after 1 year, right? That's obvious. Okay, so when time equals 0, we're investing £1 million. And when time equals 1, we're going to get 1 million plus X. Okay, and we know with investment Y, we're going to have exactly the same principle. We're going to have time equals 0. We invest £1 million. And when time equals 1, we have £1 million plus X. Or do we? Let's have a look at what's going on. So with this timeline, we've invested £1 million and we only have one compounding period. We get to X, which is 1 plus X. So let's have a look at what the calculation is. We have 1 million times 1.024. So why is it 1.024? Because we're told that it has an advertised rate of 2.4 and we're trying to uplift this by 2.4, not just work out what 2.4% of 1 million is and then add it back on, just much simpler to add it on at the same time as calculating it. That's why we put a 1 in front. Okay, so what does this equal? We have 1 million times 1.024 is equal to 1.024000. So essentially they're up by 24,000 after 1 year if they invest £1 million into an account that pays 2.4% per annum. Okay, I think that's fairly obvious. I think most of you could do that and fairly happy with how we got to that, the reasoning applied, etc. The difficulty is with account Y, actually we don't just have one compounding period like we do in X, we've actually got 2 compounding periods. Why have we got 2 compounding periods? Well, let's have a look. We are told that when t equals 0.5, we have the interest paid to us. Okay, so let's have a look at what's going on. Let's think about this. So we have 2.4% paid twice in 1 year. Okay, And what I mean by that is that we invest it at time equals 0. When time equals 0.5, we get interest. And then from 0.5 to t equals 1, we get interest again. But this is the difference. With this first period, we would have 1 million plus x. Okay, with the second period, we have 1 million plus x multiplied by x, which is also the interest period and the interest in the second period. So we're getting interest on interest within the second year, in the second half of the year. Okay, so let's just work that through again. We've got 2 periods with y as opposed to 1 period in x. So essentially, we have the same calculation for the x investment there, and then we have to uplift that amount by the interest charged in the second period. Okay, now we can do that. We can do it manually, and we have to work out what the interest rate is, etc. Then divide it by 2 and then do the calculations, and we've got x's flying about all over the place. Or we can apply the formula that you should know, and the formula is APR, or effective annual rate, or the AER, is all equal to 1 plus the interest rate in decimals divided by how many periods we're compounding each year, which is 2, but let's just write the formula down. 1 plus r divided by n times, or raised to the power of, 12 divided by n. Okay, so let's go through that formula again. APR, or the effective annual rate, or the effective rate, all the same thing. APR, AER is all the same thing. Okay, it's just APR will apply to interest charge for a credit card or a loan. The ER, or the AER, will apply to savings. Okay, so let me just say that again. That's for like credit cards, loans, mortgages. These two are just for savings. Okay, so don't get caught out in the exam. So let's go through the formula again. It is 1 plus the interest rate, the advertised interest rate, divided by the number of periods that we're compounding in each year, raised to the power of 12, divided by how many periods are in that year, n. Okay, so let's have a look at how we can get to the correct answer. So we need to plug in the figures. We have 1 plus 0.024 divided by 2. Okay, because there's 2 compounding periods. I've already said it. We had 1 and we had 2. Okay, now be very careful with this calculation. It's not 1 plus 0.024 divided by 2. It's 1 plus brackets 0.024 divided by 2 raised to the power of 12 divided by how many periods there are in that year. There's 2 periods, 6 monthly periods, so we divide it by 6. Okay, how many periods are there? There's 2. Okay, how many periods must that relate to in the year? Well, there's If it's a year and we've got 2 periods, that must mean the periods are 6. Okay, so what's the answer? We do 0.024 divided by 2 plus 1 equals 1.012 raised to the power of 2. Okay, which equals 1.024144. Okay, now what was the initial investment? The initial investment was 1 million times that 1.024144 equals times a million. Okay, equals 1,024,1. Oh, no, let's get rid of that. 1.024144. Okay, now we want to see how much extra we have by doing this. I think that was the question. Yep, how much extra interest has the fund manager achieved for us? Well, X gave us a return of 1,024,000. Y gave us a return of 1,024,144. So the extra income is £144. I really hope after all of that, £144 is there as the answer. £14.40, no. 120, no. Yes, there we go. The answer's C. Okay, so we've got to be careful. Okay, it's a case of knowing your formula and applying your formula. Now, what most students will do, they will get confused. Okay, they will shortcut this formula. Okay, and they won't apply it. Remember, it was 1 plus R divided by N. And the R divided by N is in brackets. That's the first danger with this APR, AER formula. The second danger is not understanding what's going on with the 12 over N. Okay, so let's be careful. With this N, we knew that there was 2 periods that we were compounding against. Okay, if a year is split into 12 months, okay, and we have 2 compounding periods, it must mean we have a compounding period every 6 months. Okay, and that's what we did. We said 12 divided by 6, okay, equals 2. Okay, because there was 2 compounding periods. Now, for this particular question, that's quite simple, because we could say, oh, there's 2 compounding periods, so we just do raised to the power of 2. But students will fall into difficulty if the question says actually, oh, I don't know, it was an 18-month investment and we was compounding every quarter. Then all of a sudden they fall into difficulties, they don't know what to do. However, we know what to do because we've got the understanding of the fractions. Okay, so I hope that's helped. You've been watching me, Sam Mays, and you've been watching some examination support with regards to all CII, CISI and IFS University College exams, all for an amazing value of £9.99. If you need to get in touch with me about anything you've seen in this video or you would like support, get a hold of me at samuelmays@ypsilonwealth.co.uk. Thank you very much for your time.